All right, my watch says 20 minutes to 2, so let's start. Very welcome everyone to this session, which is called End-to-End Testing Goes Corporate. In the session, I will talk about how we got end-to-end testing working properly within our organization. My name is Björn Weström. I am a software architect for frontends, and I work at the Swedish Medical Products Agency. In my spare time, I'm an open source developer, where my main project is Cypress NTLM, which is a plugin for Cypress to handle Windows authentication. And you have my contact details below. The blog isn't very active. I've been focusing more on the open source project in the recent time. Also, when it comes to questions, there will be probably some time at the end of the session for Q&A live, and afterwards I will be available in the Slack channel. I will keep an eye on the Slack channel, but I cannot promise that I'll catch everything there directly. So preferable if you take the questions in the end. Thank you. Node.js is broken in corporate environments. This might sound a bit like a harsh statement, but I think this is really true. When I take Node.js, I install it on a machine in my organization, and then I try to do npm install, it fails. And npm install is really a fundamental thing to do in Node, so it means that most of Node is broken. And what do I mean with the corporate environment? Well, it's a fairly large company, maybe 500 plus employees. IT is not the core business, and pretty much everyone is sitting on a Windows machine. There's a lot of intranet applications, and the network is a bit restricted. I have big respect for Node. I don't want to blame anyone here. I think they have made a huge success with the project of bringing JavaScript to many platforms. But I think the corporate sector, especially with Windows intranets, have not really received the attention that it needs. There are mainly 3 pain points when it comes to using Node.js in this environment, Windows authentication being one of them. There's also corporate certificates and corporate proxies. And we will take a look at all of those during the talk. So the agenda looks like this. I will first give a little bit review into Cypress, which is the end-to-end testing solution that we use in my organization. Then we'll talk about Windows authentication, how the plugin works, which handles Windows authentication in Cypress. And finally, we'll look at the other pain points of Node.js that I mentioned. So what is Cypress? Cypress consists of 2 parts. You have a test runner and a dashboard. And test runner you run on your local machine. And it consists of several components. Some of them run inside the browser itself, which gives pretty good access to the internals of the browser and allows for a nice feature called time travel. I will show a little bit later. It's open source and completely free to use. The dashboard is an optional offering. It's a portal for test execution, where you can look at the results of your tests and recordings of the tests. If you have a big bunch of test cases, and maybe you need to run them on several browsers or several resolutions, the dashboard can help out with automatic parallelization of the tests for efficiency. This is a cloud service, and the subscription is required, but if you're a really small user, maybe 3 accounts only, it's still free. And at this point, I want to mention that I'm not funded by Cypress or endorsed by Cypress in some manner. I just really love the tools that they make, and want to spread the word for other developers to share this. Okay, enough marketing. Let's look at some code. So this is a typical test file for Cypress. If you've written JavaScript tests before, I think you recognize a bit in the beginning, but to describe an if statement is pretty standard. The test suite and the test case. Then comes the Cypress commands. Cypress visit takes the browser to the root of the website we're visiting and renders that. Cypress get will fetch an element on the page using a CSS selector, in this case the ID username. And here we want to type into that element this text. So this is an input field. Then we get a button element, which contains the text lookup, and we click on that. Finally, we pick up a third element, a div element with the class display name, and check that it has the correct content, correct text content. So currently we do a username lookup here, and we see the results there. I think this is really compact and readable. I like their API, and I think just by looking at it, you can get a fairly good understanding of what's going to happen without reading their API documentation. All right, let's see it in action. And while we're waiting for that to load, take a look at this picture. If you recognize that picture, that probably means you're about as old as I am. So this picture is from the PC demo scene, classical demo called The Second Reality by Future Crew, which was released in 1993. Back in that time, that was a really impressive display of computing skills for me as a beginner in the PC scene, and it's been an inspiration for me to pursue a career in software development. All right, so here's Cypress. This is the test runner. In the test runner, we can select which test we want to run. We can look at the configuration that's being used at the moment, and we can pick which browser to run the test. So this is the test case that we looked at the code for just now. And there we go. So there are actually two test cases here because I wanted to show also how a failing test works. The first test is exactly the code that we looked at before. We visit the page, we fill in the form, and then we check the contents. Nothing strange here, except that we can see the actual steps of the test in the browser, which is really nice. Here comes the time travel feature. So when I hover over one of the steps, it will show on the right-hand side how the page looked at that particular step. And when I hover over a step that selects something, it will highlight that element. So it's pretty easy to see that it will write John Doe into this input field. And it's easy to see that I found the right button to click on. And then when I do my assertion, I can see that it's the content of this element that I'm asserting against. So really, really powerful both for the development of the tests and also for debugging when something goes wrong. If I look at the failing test, in this case, I was typing in the username foo instead of jdoe and expected that Mr. Foo should be a user in the system. But apparently he isn't. So either he's missing in the database or there's something wrong with my test. Then I can scroll down and see this is the actual line in my test code where the assertion failed. So it's also very readable, I think, and makes it easier to go back to it. In other solutions that I worked with, usually you were happy if you had a screenshot maybe of how it looked when the failure had already occurred. And then you had to rerun everything locally, but this helps a lot. Just to demonstrate how easy it is to run in a different browser, let's go with Edge here. And it launches the Edge browser and runs the same test suite again. Or it should. I think demo gods aren't happy with me at the moment, so let's just retry that. Okay, here we go. So same test set, same result. No surprises. But still, just by changing this dropdown, I can select which browser I want to run in. It's really, really nice. Okay. So let's talk a bit about how Cypress works on the inside. What we saw, the UI is Test Runner, which is an Electron app where you can select and start your tests. In the background, there's a server component running a node. So when we're starting a test, it will tell this test runner to execute that one, and the test runner will launch a browser window. And the browser window hosts a test runner client. So that was this panel that you saw on the left-hand side with the testing log and the results. Then when the test runner is ready to start the test, it will receive commands and pass back results to the test runner server. You can tell the browser to navigate. This is done natively by the browser, actual network requests, but the network requests are proxied through Cypress test runner server before they reach the network. Normally, this traffic just passes through, but I will get back to how this can be helpful also. And then we have our application loader here. Now it's possible for the test runner client to simulate user interactions, such as typing in fields or clicking at things or scrolling or whatever. And we can also inspect the DOM to see that it has elements we expect, or that elements contain what we expect. To be fair, if you're running the Electron browser, like I did in this demonstration, it's actually the same process. The test run UI and test browser is running the same process. But this is more of an architectural detail. When you have a separate browser, like Chrome or Edge, it will look like this. And for the rest of this talk, we're mostly interested in communication between the components and not which process the components are running. So how does this make Cypress different from Selenium, for instance? We can start with the test runner client. Quite obvious because there's no display of the test execution or test result inside the browser when you're running Selenium. This is also a big benefit because it makes it easier to debug things. It allows this time travel feature that I showed, that it records the DOM at each step of the test. Waiting for elements to be available is much faster and smoother and stable. The next part is the test run UI, where you select which tests to run. This is also not something that you see in Selenium. You will have to start your tests usually from your developer ID, like Visual Studio. So I think this makes it a lot easier to get started with Cypress for non-developers. And then we have the proxy for network traffic. And the thing with the proxy is that this allows you to mock responses and responses to requests. So you can mock an API that is required by your application. And this is very powerful. That means you could try out error scenarios or edge cases that might be difficult or nearly impossible to replicate when you're running in a full environment. It also means that you can short circuit certain parts of a longer flow in your application to make your testing much more efficient. How about authentication? Well, there's built-in support for basic authentication. You pass an auth option to the visit or the request command. And if you're doing any authentication that doesn't really require a client-side protocol, that will also work fine. If you're logging into a web form or a JSON web token solution. The reason is that with these kind of logins, all you have to do is to write the steps in Cypress to fill in the form to do the login and click the button, and then you go. So those will be just fine. So if you're an internet-facing app developer, you might say, this looks sharp, let's use this. But if we're a corporate internet developer who says, meh, what about Windows Authentication then? Yeah, what about Windows Authentication? Windows Authentication, its full name is Integrated Windows Authentication, and you use it in a web context. There are many other names, historical names. NTLM is one of the protocols. Negotiate is another of the protocols. So it's actually a bunch of different authentication protocols that you can use for intranet websites or APIs. And it validates the user against Active Directory or local machine account. And for a long time, this has been the primary choice when you select how to do intranet authentication in corporate setting. There are many methods. I mentioned basic authentication is a classic that many know about. And NTLM and Negotiate were the ones I mentioned before. They have their different pros and cons. And if you look at which ones are supported by Cypress, it's everyone except these three. I don't know about you, but I don't know many people using Digest anymore. There is an open support ticket with Cypress for it, so someone still needs it. In my case, we needed NTLM or Negotiate to use this against our own applications. So that's why when I first saw Cypress, I felt that this is something that we really need. I want to try this out. I think this would work better for us as end-to-end testing solution, but there was no support for Windows authentication. So how I got the idea to start working on such a plugin. So which way to go? Should I choose NTLM or Negotiate? Well, if you look at what my plugin is called, it's called Cypress NTLM Auth. So I think that gives it away. And why did I pick that? Well, have you ever looked at the specs for Kerberos? Of course, you can master that too, but it felt like a stretch for me to implement a solution that will support and Negotiate fully, just as a side project to get this working for trying out Cypress in our organization. NTLM felt like a much closer goal. I had some prior knowledge in how NTLM works. There are some open source libraries available. And also I wanted it to be platform agnostic. The thing is that NTLM, you can calculate everything in the message exchange locally on your machine. With Negotiate, you need to talk to Active Directory, other parts of the network to get your tickets to be able to complete the authentication. So this with NTLM, we could be fully independent and run authentication flow without those dependencies. Let's have a look at the NTLM handshake, how that works. So it starts out with a normal GET request for the site ntlm.acme.com. The response is a 401, not authorized, and you get a special header here called VVV Authenticate, which specifies which protocols does this server support for authentication, NTLM or Negotiate. In the next step, we send another GET request, just like the first one, but we add an authorization header where we add the first part of the NTLM handshake. We get another reply with a 401, and now the replying header contains a reply to our NTLM message. We make a third request with the third part of the handshake, the last part. If everything checks out, we will get 200 OK with the full page served in the end. In type 2 step, the server sends us a nonce value and a timestamp. The nonce value is a random string, and the timestamp is just a timestamp. These two together, they prevent hacks where you try to replay a handshake against the server again, because the nonce value will change every time you try to negotiate with the server, and of course the timestamp also changes. And you have to put those values into the hashes, the hash calculations that you do when you create your third message. So therefore, third message is dependent on the content in the second one. Also, you use the password of the client as a key when you're hashing parts of this message. So that's enough to prove to the server that I have access to the password for this user. I don't have to send the password. I don't even have to send a regular hash of the password. I just use it while hashing. So that makes it fairly secure. Sure, I guess you've heard about there have been incidents related to NTLM over the years, and it's not so strange. It's an authentication protocol that's been around for a very, very long time, but it has been improved over the years. So even though there are some that are recommending that you should move away from NTLM, I think as long as you stick to the latest version of NTLM and require the clients to use that, then you're fine, at least for a test environment. Okay, let's talk about the plugin. We'll see how Cypress behaves when we try to access a page which requires Windows Authentication. All right, the first test, I access a page which only requires anonymous access, so that's fine. In the second step, I try to access a URL which requires Windows Authentication. And the response is a 401. If I scroll down a bit, it prints out here the response message that we got. And it was a 401 with the special header that we saw before, and when I described the protocol. And it says, I support negotiate in NTLM. So go ahead and try to authenticate with one of those. But at that stage, Cypress doesn't do anything more. It just drops this, and I will get back to why later. There's a third case, and that is if the page itself doesn't require authentication, but you use a background callback to find the API value, and that one in itself requires Windows Authentication. Then the rendered data won't be what we expected in the test. So why doesn't this work? Let's see. We have our test runner client, which is telling the browser to navigate to our page. We send a GET request for a protected page. It passes through the proxy, and the proxy sends it to the network. And the server replies with a 401 because it doesn't know who we are yet. It invites us to authenticate. And at that point, the test runner server says the test failed because we got a 401 and we can't render this page. Now, if we hadn't been running Cypress, if we just had been running the browser, instead we would have seen an authentication dialog where we should type in our username and password, because the browsers support NTLM and negotiate usually. So why doesn't this happen when we use Cypress? Well, because that authentication dialog is a native dialog for security reasons. So the automation tool cannot access it. It cannot write anything there. So if Cypress would allow that pop-up to show, it could still not proceed with the test after that point. It's pretty pointless to have an automated test where you have to manually type in your username and password somewhere in the execution. And because of that, Cypress configures all browsers that it starts not to do any such kind of authentication attempts. Authentication is handled by Cypress itself when it's able. So how can we make it work? Well, we have to put another proxy in front of Cypress proxy. Now when we navigate, we get our request going out. It will pass first through the Cypress proxy and then through our NTLM proxy. When the NTLM proxy receives the response, which is a 401, it will perform the full handshake with the server. And when the handshake is finished and we get our 200, we pass that one back to Cypress, which passes it to the browser, and the test can continue. So from Cypress' point of view, it doesn't even know that authentication took place here. It just sent out a GET request and is happy with the response it received. How can you make plugins in Cypress, and what can they do? There is a plugin API built into Cypress where you can access and modify the configuration. You can act on event callbacks, but there's a bit of a limited selection for those. And you can write custom commands. And a custom command is kind of like a shortcut. You can take a bunch of commands and put them into one, or like a function that you bundle with Cypress to make it the test code a bit more compact. And it is possible to modify requests and responses with this built-in proxy that I mentioned before, but it isn't possible to drop responses completely. To simulate the whole, or to handle the whole handshake, we have to drop the 401 messages that are coming in from the server. And since we can't do that, the only way to solve this is to have an external proxy. And the external proxy that I wrote is called NTLM proxy. It has a web API, which you call to configure which NTLM hosts it should support and which credentials to use for those. For any unknown host, so that's a host that isn't configured as NTLM host, it will forward the HTTP traffic and it will tunnel the HTTPS traffic. So it's just transparent proxy. For the configured host, it will intercept the traffic and it will then apply an NTLM handshake when it is needed. So if it receives a 401, it will start the handshake process and it will not return anything to Cypress until the negotiation is complete. Yeah, the handshake is done transparently to Cypress, I mentioned that. And this part, the NTLM proxy, is usable with something else than proxy. There's not something else in Cypress. There's nothing that ties it to Cypress itself. It could be used with Selenium or any other application where you need to add NTLM authentication support on top of it. HTTPS traffic is a little bit tricky to intercept. To do this, we have to act as a man-in-the-middle proxy, which means that Cypress is connecting to our proxy, and we act as a server towards Cypress. And our man-in-the-middle proxy connects to the site and acts as a client towards the site. So the traffic is encrypted between the man-in-the-middle proxy and the site, and between Cypress and the man-in-the-middle proxy. But it isn't encrypted inside the man-in-the-middle proxy. That is required because otherwise we couldn't know if we receive a 401 message that we need to act on to do the handshake. This is a bit involved, and you have to also generate certificates for all the sites that you are mimicking. So I was very happy to find that there was a competent package already available. It's called HTTP man-in-the-middle proxy. It's maintained by Joel Ferner. So big kudos to him. It's a big building block of the NTLM proxy. I would also like to mention Nico Haller maintains the NTLM client package, which was a good inspiration for me implementing the NTLM protocol and all the algorithms for that. So now we have the proxy. How do we bundle it up as a proper plugin? Well, I added a launcher, which streamlines the startup, because now if you want to run Cypress with Windows Authentication, you have to start a proxy and you have to start Cypress. And these two have to know how to communicate. So they're started together, and through the plugin API, I inject some configuration so that Cypress will proxy all its traffic through the NTLM proxy when it's coming out of Cypress. I also added some custom commands to simplify the usage and test code so that you can easily add new NTLM hosts that should be included by NTLM proxy. How do you set it up? Well, there's detailed instructions in the README file in the repository, but let's go through it briefly. You do the npm and install, of course, and then you configure Cypress, 2 files, plugin file and a custom command file, and then you add a few lines of scripts to package JSON. These are the Cypress configuration files. The top one is to register the plugin, which modifies the config, and the bottom one adds our custom commands. And here's the package JSON additions. These are slightly different depending on which platform you're on. This is because the NTLM proxy should be started as a background process, and the commands to do that are a bit different on Windows than on Mac OS and Linux. I have received a few questions on GitHub issues for my plugin where people are asking which package JSON file they should edit. So to me, it's clear that some of the people trying out Cypress and trying out my plugin, they are not really used to using Node or NPM. so it was a bit confusing to them, and they sometimes ended up trying to edit the package.json file within my Node modules plugin folder. But of course, you should edit just the package.json in your root project folder, the same folder where your Node modules folder is already installed things. The custom commands that are added are these. So we have the NTLM command, the NTLM single sign-on command, and the NTLM reset. NTLM command is used to add a single host with NTLM authentication. And then you pass in the specific username and password that should be used. You can, if you need to, you can specify which domain that user belongs to. You can specify the name of the workstation. Otherwise, it will take the name of your current machine where you're running a test. And you can even state which NTLM version should be used. So you can force it to run in NTLM version 1, which you really shouldn't be doing unless you have to for communicating with some really old legacy system, because that has been broken for a very long time. If you need to add multiple hosts, you just call that command multiple times. The SSO command is a lot simpler because you don't need to add any credentials. This will do a single sign-on using the same user that you log on to the machine with. So you just specify a list of hosts or subdomains which should be accepted for single sign-on. So if the proxy detects any 401 messages from any of these hosts, it will initiate a handshake using single sign-on. Another benefit of the single sign-on is that it actually even supports negotiate, because it uses internal Windows API calls to perform the single sign-on, and those support both NTLM and negotiate. The drawback is that it's not available unless you're running on Windows, because we're using Windows API, so it's quite clear. And you're only logged on as an Active Directory user to the machine if you're on Windows. So also in that sense, it wouldn't really make sense to try to do single sign-on from another platform. This is a cleanup call. It will remove all the configuration, and it will also close any open connections that are still ongoing to any of these hosts that you have configured. So that's good practice to put that in before each statement of your tests. When all this is set up and done, you can simply do npm run Cypress NTLM to start. So let's see it. Now, I know that when you're on the stream connection, this might just look like a blur, and it probably did because it ran 8 different tests in 3 seconds. I think it's kind of impressive because it's a full web browser, you're loading a full page, even though it's a rather simple one, and you're doing some assertions or typing or clicking on those pages. And still, you can execute 8 tests in such a short time frame. It's really nice performance with Cypress. Let's look at first one where we needed to do sign in. So we go to an authenticated web page by clicking on the authenticated tab here, and it will just pass in. I've just added this to the page so it's clearer that we're logged in or if we're not logged in. So you can see the status according to the server. But from Cypress perspective, it doesn't really know that something happened in the background. The only sign of it is that here we call this NTLM command to add this host to our pool of hosts that we will apply NTLM authentication for. The single sign-on case is similar. It's just that we can do it a bit simpler. We do a wildcard with subdomain. Here we have multiple sites when we both need to authenticate to something on the page and we need to authenticate to an API. We have both of them here as 2 calls. And with SSO, it would have been just 1, since it's a wildcard. All right, looking good. So let's review some code from this demo. This is the source code file. Let me zoom in a little bit. So the first case that we looked at was this one. We called NTLM, and we set the host name, username, password, and domain. I like to keep those separated in an environment file. There's two reasons. One thing is that you need to use different users when I'm running this in different domains. So I need to inject that in my CI. And secondly, I like to keep my test files together with my source code in Git. And you shouldn't really be committing user credentials to Git, even if it's just testing accounts. So I think it helps both ways there. To use those, this picks up either normal environment variables, or if you're running locally, you can have a file like this, Cypress NDC which will specify those on your machine. So I've added this to git ignore so that it doesn't follow into Git. Okay, that was with one host. That was the single sign-on case. And this was with two hosts, one at the other. There's also IntelliSense if you've forgotten something about the syntax of these commands. Okay, let me talk about a few challenges that I faced while I was developing this plugin. NTLM keeps its session state through an open TCP socket. This means that the TCP socket needs to be open and kept alive during the whole handshake. Otherwise, the session is lost and you have to start over. In Node, there are multiple keep alive concepts. There's a keep alive concept for the agent, which is handling requests, and there's a keep alive concept for the HTTP connection, which is set in headers. So I had to figure this out to put those together in the right way to get it working. And I think the worst challenge was this one. The only thing that you get back when you fail to authenticate is a 401 message with no explanation. That makes it extremely frustrating to debug authentication issues. Of course, there's a good reason for this. You shouldn't share more information than necessary in error responses, especially when it comes to critical things like authentication. So I have understanding for this, but still, it makes life difficult as a developer when you're trying to implement authentication protocol. You add on top of this that I've been helping several users remotely through GitHub issues. We've been trying to get work started with the plugin. That's also really quite demanding to do this kind of troubleshooting, since they only have this 401 response to share with me. I had to add quite a lot of extensive debug log functionality to the NTLM proxy to be able to help them better. And lastly, there are several NTLM client implementations available as open source, which you can use for inspiration, but there's really nothing much when it comes to the server side. And that makes the testing harder, of course. I think the 0.2, the one that you only get for these responses, it would have been easier to work with that if there was an open source server-side solution where I could debug and see where is it failing, which part of the NTLM message is still incomplete. But that's how it goes. Okay, coming into the final part. We've now handled Windows authentication, at least for Cypress and end-to-end usage. So let's proceed with corporate certificates. I mentioned in the beginning that if I try to do the npm install on a machine in my organization, this is what I get. I get an error for self-signed certificate in chain. Now, if you're working in a corporate organization, you probably know the drill. This is somehow ended up in a SSL decryption device. And you might apply to the infrastructure team that they should add this host name to the exception list. But corporate organizations are usually a bit bureaucratic, so this means you have to speak with several managers, and some of them don't really know what you're talking about. But let's say that you pull that off and finally made them to put this on the exception list and installed Express. Then what? Then you try to install Cypress, and boom, you get the same error again, but in another variant. Also, here we have the self-signed certificate. Why? Because Cypress will download additional binaries. It won't only take things from the NPM repository, it will also take things from their own repository. This is not uncommon among packages to fetch additional data from other sources. So I think you realize now that this is not a viable solution to keep adding things to exception list. There's got to be a better way. First, let's try to understand the problem. So Node.js is running behind a corporate firewall, which introduces a corporate certificate. Because a corporate firewall commonly applies HTTPS inspection. HTTPS inspection is nothing less than what we mentioned before. It's actually a man-in-the-middle proxy where you decrypt the traffic to analyze it, and then you encrypt it again with a new certificate before you pass it on to the client. So if you don't have HTTPS inspection and you go to a site from Stack Exchange, you can check at the certification path, see that the root certificate is from DigiCert, which is a well-known certificate authority. And then there's an intermediary set in between. That's pretty common standard setup. But with HTTPS inspection, the root certificate and the intermediate certificate are replaced. This is because that's required when we decode it in the HTTPS inspection, in the man-in-the-middle proxy. We have to replace it with something else because we have to encode it again, and we don't have the private key that is used by Stack Exchange to simulate what they're doing. DigiCert, as a well-known CA, is known by browsers and by Node, so they trust it by default. Our corporate certificate, the Bank of Evil Root CA, is probably installed in our machine's certificate store. So that will be trusted by the browser, but that doesn't mean that it will be trusted by Node, actually. Why? Because Node doesn't use the computer certificate store. Node has its own certificate store for CAs. So how can we work around that? Well, there's the shortcut, the cheating way. We set this environment variable node TLS reject unauthorized to 0. And then you have disabled all your certificate checks in Node. I sometimes do this just for verifying that the errors that I'm getting are really originating from a certificate error in Node. But please remove it directly after you've made that check, because this disables very important safety features of HTTPS. Anyone can act as any HTTPS site to your Node implementation when you have this on. My recommended approach is to use another environment variable called node extra CA certs. And this variable should point to the full path of a file, which should contain a CA certificate in PN format. Or it could be a bundle, so you could concatenate together a few CA certificates if you need. And this will tell Node to accept any certificates that are issued by any of those CAs. Note that this requires that you have a full CA chain. You cannot just put in a self-signed certificate in this extra CA such path. You have to have full chain. So how do you get hold of that certificate that we can add to this environment variable? Let's say that this is the site where HTTPS inspection is applied. Then we can click on the padlock, and then we click on certificate. And here we have info dialog for the certificate. We click on certification path, and there's the hierarchy. We go to the root certificate and click view certificate. Now we have another info dialog for the root certificate. We go to the details tab and click copy to file. That starts a wizard. You can use the default options, except in this page, you have to select base64 encoded X509 for it to be compatible with Node. And then you select where to store it. You can choose whatever you want, as long as you take note of this path, and this is the path that you should then put into the environment variable node extra CSH. And then you're good to go. There is another more general solution. There's an NPM package called WinCA, and this one loads all the CSH from the Windows Search Store and makes them available to Node for HTTPS connections. So that sounds great, right? You just do npm install WinCA, and then you require it in your application. But what's the catch here? Well, we needed the CSF to be configured before we even could do npm install. So we can't even install this package if we haven't done the previous configuration steps. Of course, you can work around that. You can download this package manually and install from a file. But still, you're stuck with having to put this require statement in all the applications where you need to have HTTPS access. I think this can work fine if you have a pre-packaged application that already uses it, like Electron Solution or something. Then it's great, but generally, when you're starting up with Node, it won't be much help, I'm afraid. Okay, that was this corporate certificate. And finally, the proxy. So the proxy settings that you should pass to Node are these. HTTP proxy environment variable, set that to the proxy URL. HTTPS proxy environment variable, only needed if you have a specific URL for HTTPS traffic. Otherwise, it will automatically use a URL from HTTP proxy. And then you have no proxy, where you can add exceptions. This is pretty important because you usually don't want that traffic to localhost is passed to the proxy first. You want that to go to stay internally on your machine. And probably you also want to exclude any intranet sites because you're not going out to the internet, so you don't need to go to the proxy. So it helps with performance, and also I think it won't even work for some scenarios if you proxy the wrong things. In our organization, we actually don't have the need for setting up the HTTP or HTTPS proxy. So maybe you do, maybe you don't. You will know if you try to use Cypress and you see that it cannot access any external resources that you try to load. So then you know where to start looking. There's a bonus here, single sign-on. This isn't directly related to the Node pain points or end-to-end testing, but it's a developer pain point, at least for me. When you have a corporate environment, you usually have a pretty good setup in your production environment where you're getting single sign-on experience to all your intranet websites. You don't need to enter your username and password anywhere except when signing on to the machine. But then when you're moving to test environment or development environment, you usually don't have that luxury anymore. And maybe you didn't know, care to figure out why, but I think over the years, quite a lot of login prompts, you can save some time by getting single sign-on to work in other environments too. And the trick here is trusted sites. So in the internet options in Windows, you can add trusted sites, right? And trusted sites will allow the browser to use a single sign-on authentication when trying to go there. It could be the case that you're not allowed to add trusted sites yourself. They could be managed by GPO. In this case, you can ask your infrastructure team to add them. Usually this will be domain specific. You don't want to have the development domains single sign-on enabled on production computers, that you want to keep that together so that development domain computers will have single sign-on to development domain sites and so on. This works fine for Internet Explorer, Edge, and Chrome because they all pick up these settings. Firefox has its own configuration for single sign-on. You can look that up if you need it. So the main takeaways from today's session: if you want to use Cypress with Windows authentication, use my plugin, Cypress NTLM Auth. If you need to use Node.js in a corporate environment, then make sure you handle your corporate certificates and proxy settings, and then you're good to go. Thank you very much for attending my session, and also special thanks to the NDC organizers for letting me speak here. This is my first session as a speaker on a larger developer conference, and it's been an honor to get this opportunity. So thanks very much. All the slides are available in the link here, and you can find source code for the demos that I showed, a link to my plugin, and my contact details. So thanks again.